Hello students, welcome back. And in the previous video, we already learned about the ticker tape. And in this video, we are going to look at the linear motion graph. I'm sure, actually this you learn very well is very good. Because this one question not only come out in science, but it come out in mathematics as well. So when you go for a mathematics class, when you learn the linear displacement graph, please read it and learn it. And when you go to science also, you learn it properly, because when you learn one thing, you can use for two subjects, science and mathematics. Yeah, so just make sure that you do this. I'm sure exam mathematics they can come out, or even the science. Displacement time graph is the changing of this is the graph. The first thing to do is to look at this unit, displacement over time, not to be confused with speed over time. You see the difference or not? If we are talking about speed over time, it still can be like this. It means that something like this. It can still be like this. Means the speed increase, then the same speed, the speed increase again, the speed decrease. So it can be like that. Or it can be acceleration over time. Acceleration over time, is it possible? Yeah, possible as well. Not possible. Not possible. Okay, anyway. Let's erase this one. To make things simple, this is the first keyword. Displacement over time. Time over displacement, or speed over time. That is the difference. If you didn't get this correct, you will do it wrongly, because the question might ask either is velocity or acceleration. So if velocity is the distance divided by the time, and then acceleration is the speed divided by the time. So it's totally two different things. So just remember, speed and displacement, you look at the graph, you make sure the graph is either displacement time or speed time. Then we look at the question. Okay, let's look at the question. Is there a question? Okay. Let's say the question is explain the graph. Okay, let's say Ali, now I want you to go in front. I want you to explain to me what is this graph. What is this graph about? So I'm Ali, I will say, okay, this is displacement over time graph, means this is actually like distance, right? So first, let's say this is a car. A car move 50 meter. Okay, he moved to 50 meter, because here is the meter already. Then he stopped. You say he didn't go already. He stopped. After he stopped, then the car moved again for probably 8, 9, 10, 11, 12, 4 seconds. And then the car go back with a uniform speed until 0. Move back until the displacement is 100 meters from the starting point. So it's 0, 0 displacement. Distance is 100 meters. Displacement will be 0. Correct or not? Because we are talking about displacement. So displacement, go 50 meter, then go back 0. So the displacement, I'm not sure whether you can understand or not, but hopefully you can. Displacement is 0. How about the distance? Why don't you pause the video and tell me what is the distance that the car has traveled? Okay, let's look at the distance. That's why I see why I calculate so long. Okay, first the car moved 50 cm, 50 meter. Then the car stopped. Stop means 0 plus 0. Then plus what? It moved up again, 50 meter. We are here to here 50 meter. Then he come down again. Come down is 100 meter. So he get 200 meter. So the distance is 200 meter. Yeah. Yeah, makes sense. 200 meter. Let's say I give back this same question. I change this to speed. Where's my eraser? Let's say, so the displacement, assuming this is displacement time graph, if I change this to speed, I don't want this one. I want this one, speed. I put the unit meter per second. Can you tell me the distance? I should use green color pen or other color. Where's the color pen? Maybe I use green color. Okay. Let's say this is speed meter. Can you tell me the distance? Okay, you can pause the video and try. Yes, correct. Okay, so if you get 850 is correct. So you just need to calculate the area. So 50 times 2 divided by 2, because it's a triangle. 50 times 2 divided by 2, you get 50. And then here is 50 times 8 minus 2 is 6, right? So here is 6. 6 minus 50 is 300. And then here is how many? Here is 4 seconds. This is a trapezium, so you can either calculate half or you just calculate everything easy. I calculate everything easy lah. So 100 plus 50, this is 100 plus 50. 150 divided by 2 is 75. 75 half this one plus this one divided by 2, 75 times 4, you will get 75 times 4, how much you get? 300 also, is it? And then this one is how many seconds? 4 seconds times 100, 400 divided by 2, you get 200. 200 plus 300 plus 300 plus 50, you get 6, 7, 8, 850. So you get, I just write 50 plus 300 plus 300 plus 200, you get 850, the unit meter. I remember the unit. If you don't write the unit, then you will get wrong. So you can see that it is a totally two different thing. This is also distance, this is a distance. But the first distance I get 200, the second distance I get 850, because it depends on the table. Either it's a speed time graph or displacement time graph. So you be very careful. Well, I think students will always do wrong and they get confused. Why the book like this book say like this? Why that book say like that? So it's actually not because of the book. It's because the graph look almost the same. It's not the same. So you need to understand the concept of speed and the concept of displacement, and they can always, or one more is distance, if they want to give distance time graph. So it also, but distance and displacement almost the same. Yeah, but usually they won't give distance. Let me think. 50 distance, add 15 distance, then you reduce it. Yeah, almost the same. So there is not much difference. Yep, so that's the concept. I hope you can understand. Velocity time graph. Yes, velocity time graph. Oh, yeah. I put here just now, I put here speed, right? I should put here velocity. I mean, it's the same lah, almost the same lah. Speed and velocity is almost the same. Only one use displacement, one use distance, okay? But it's the same. So we can see that at first, the speed increase means there is an acceleration at here. Acceleration increase, acceleration decrease. So you can see that the car is becoming more and more faster and faster. Here is can you here is there acceleration? Never mind, I asked the wrong question. Too complicated already. I don't want to go to that topic. Okay, anyway, so accelerate, and then here is not stop. It still move at 8. So move at constant speed. Like the car, 0 to 80 km. And then your daddy see the signboard 80 km. So your daddy very good. Daddy just follow the speed limit 80, 80, 80, 80. Want to reach the grandmother house already. Slow down, 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 slow down. Stop. Yes, so it go fast. The car go fast, and then same speed. Then slow down, slow down, slow down. Stop. Unless, but usually car will be like this lah. Because the car will be very fast, right? So it will be vroom, go up, and then the car will be stop. But not because your daddy step the brake ma. So you if the car like this, boom, means the accident already. So you can see there's accident here. Straight away stop. If you press the brake like that, this one is you don't want to press the brake, you just slowly let it stop. Slowly let it stop. Okay, so that is the difference. So we depend on the gradient of the car. I mean, if I want to buy a car, I want to buy the car that has this gradient. So means it can go fast in very short time. I don't want to buy the car that like this. This is ganchiu, old car, because the speed very difficult. Okay, and then if this car go fast, this is Maserati or Ferrari, go up very fast. Come down almost the same lah. All car also got a brake. So I hope you can understand. So I'm talking about speed time graph. I'm not talking about distance time graph. I'm not talking about this one, the distance. Again, I tell many times already, so I tell again. The graph, displacement time graph. Okay, so this question, displacement time graph. What is the displacement of the toy car in 4 seconds? 4 seconds at here. Displacement 4 seconds. 4 meter lah, correct or not? 6 meter. Oh, sorry, short already. 4 seconds. 4 seconds is at here. Okay, so of course it's the 6 meter. So we can see that the answer is 6 meter. And then what is the velocity of the toy car? In the 3rd and the 5th second. So there are two questions I need to do. The first one is the 3 second. Another one is the 5th second. The velocity. And this is 4. This is 8. Velocity equals to what? The formula. The velocity equals to distance divided by time. So the question wrong again, is it? Anyway, velocity of the toy car. From here it says from 3rd to 5th second. Yeah, I think the velocity cannot be calculated because this one is here. I think here they should ask what is the acceleration. Is it the acceleration? Yeah, correct. This one I did wrong. Correct. The book is correct. Okay, because here is displacement over time, so you just need to find the velocity here is the same. Okay, I mean the speed the velocity. Here the speed, if you look at the table, and here the speed, and here the speed, and here the speed is the same. Why? Because it is a straight line. It's a straight line go up, doesn't mean it increase in speed. It increase proportionally distance and time. As the same time of distance increase, the ratio for the time increase the same. How I know? Because it is a straight line, unless it's not a straight line. So when there is a straight line, there is a uniform of increase in speed. Uniform increase in speed. So how to do this? Mathematics question, you just find the gradient. So maybe you just draw a triangle at here. Okay, triangle at here. So triangle at here, y m equals to y minus y over x minus x. Okay, so here is 4 divided, here is 4, correct or not? 8 minus 4 is 4. Here is 1 2 2, so it will be 4 divided by 2. Y minus y divided by x divided by x, you get 2. The unit for velocity, ms negative 1. Okay, ms negative 1. So you get the answer. Just now I'm confused. I thought I need to find gradient because let's see, is there a gradient graph? Yeah, because just now I'm confused with the gradient. So what am I confused just now? Let's say the question asks about acceleration 8 to 12 seconds. 8 to 12 seconds. So again the same thing, because this is velocity. So let's do a triangle. So the triangle here, it will be 3. Here 3 is at here and 4 is at here. So 3 divided by 4. So you can see negative 3 divided by 4, you get 0.17. So I put here 0.75 ms negative 1. Okay, if it increase, it is 0.75, but since it come down, I put here negative. Okay, I put here negative. So the acceleration is negative 0.75. Okay, I think it's a lot already. I don't want to go too much. Maybe the next video we will focus more on the acceleration and deceleration. I think for this topic, the most difficult thing is this unit, velocity over time and displacement over time, or speed over time. Then you got different thing, and the formula is the same, because just now when I use for displacement over time, I get the velocity, means I find the gradient m equals to y of minus y divided by x over x. But for the same thing, I find the gradient, I get the acceleration. So what is the keyword? The keyword is here. The graph, either it gives you velocity or the graph it gives you displacement. So if you don't understand that, then it will be a bit difficult, but you can ask in the comment. So maybe some of your friend or me, if I see the comment, I can help. And one tricky question about this is, when the question asks about acceleration, I put negative. If the question asks, I don't think the question will ask unless the teacher want to give you a hard question. What is the deceleration? If the question asks deceleration, you need to put 0.75. You cannot put negative, because deceleration means negative already. So if the question asks deceleration, you just put 0.75. If the question asks acceleration, and because it's negative acceleration, you need to put negative. So sometimes this is also the difficult part, because you don't know want to put negative or you don't know want to put positive. But it depends on the question. You get what I mean? If the question asks acceleration, you put negative. If the question asks what is the deceleration for this question, then it is positive, negative 2. Yeah, okay. So that's it. I think this is very difficult to teach because it's a video. I think this one student can learn more by doing exercise. So I want you, as your homework, you try to do by yourself this textbook. You don't look at this first. You can look, then you try to close it. then you do this few questions, you close it, see whether you can get the answer. If you can get the answer, well done. If you cannot get, try to ask yourself, ask me, or ask your friend, as long as we learn together, okay? Then it will be very helpful, because when you learn this, it's not only for science, but it is for maths question as well. So that's it. Okay, so I teach until here, and I see you in the next video. So I see you again. Thank you and bye bye.
Thank you, teacher.
Bye bye.